You see that what I've got here is a car. It's tied to a thread, to a hook, over a pulley. I've got 4 washers. And when you do this experiment, they'll be identical washers, but I've got 4 washers here. They're not exactly identical. And I just dropped 2 of them. Reach down here and get this one. Now I put the 3 washers back on top of the car, and I put this washer around the hook. When I remove the marker, the car might start accelerating. Let's see. Nope. If we give it a little bit of a nudge, it'll accelerate. So there's sufficient weight on there to accelerate the cart down the ramp. If I take another washer, put the marker there to prevent the car from running off. Careful about that. Okay, remove the marker, and the car again accelerates, this time a little bit faster. Now, of course, if we add another washer, we're going to expect acceleration to increase even more. And that's exactly what happens. And we can continue adding washers. Now, we want all the washers to originally be sitting on the car because we want the total mass of everything, the washers, the hook, the string, and the car, to always be the same. What is it that causes the acceleration? Well, acceleration is caused by the gravitational force on these washers pulling down. That downward pull is going to have the effect of stretching the thread slightly. This is a very low friction pulley, so any stretch the thread gets on this end is also going to be felt on this end. So any stretching force is going to tend to pull the car forward while it's holding the weights up. So by adding weights here, if these are identical washers, we increase the force of gravity by the same amount each time. That force is transmitted to the car, and the whole system then accelerates forward. And of course, we measure that acceleration by measuring the time it takes the car to go from rest through a known distance.